Welcome to the Royal Oak Church of Christ. Thanks for joining us, either in person or online. Certainly happy to have you with us tonight. If you haven't already done so, for those that are in attendance in person, please silence your phones. Good. Tonight we have a special guest speaker, Dr. Michael Houts. And by way of a resume, Dr. Houts works at the NASA Marshall Space Flight Center, where he manages a team of about 70 engineers in the area of nuclear propulsion and design. Dr. Houts has authored over 24 articles, as well as co-authored over 100 more. Among his many achievements, last year, NASA awarded Dr. Houts its most prestigious award, that is the Distinguished Service Medal. Congratulations. Dr. Houts is a bona fide rocket scientist. But more importantly, that is more importantly for us, since his baptism in 1999, Dr. Houts has used his knowledge about science to explain many of the teachings presented in the Bible. In last night's presentation, that was entitled Unmasking the Science, Dr. Houts exposed all kinds of deceptive practices and fake science that the evolutionists use in promoting evolution. Tonight, Dr. Houts will discuss assumptions and the age of the Earth. There will be a question and answer period following his presentation at the end, so please write your questions down and we should be able to get to those following this presentation. With that, let me introduce you, warm welcome, Dr. Michael Houts.
Well, thank you. I'd like to thank everyone for being here tonight. Again, it was really a great session last night. Appreciate the questions and the discussion. And what we'll be talking about tonight, again, is the assumptions and the age of the universe. Again, a very important topic. I do, again, I want to especially thank the congregation here and the elders here for arranging for these talks. But did want to start out with just a summary from last night. The first point is really keep the goal in mind. And what we were using as our goal was Ephesians 4:14 through 15. As a result, we are no longer to be children, tossed here and there by waves and carried about by every wind of doctrine, by the trickery of men, by craftiness and deceitful scheming. But speaking the truth in love, we are to grow up in all aspects into him as the head, even Christ. And so again, we need to make sure that we're not carried away by, in the words, craftiness and deceitful scheming, trickery of men. We need to make sure that we're not carried away by that. But when we're talking about the subject, we need to make sure we're speaking the truth in love. And a lot about speaking the truth in love. One of the first things, of course, we need to do is make sure this is really a subject that's the person's struggling with. A lot of times people will say, well, they know God created the earth, but they're struggling with this other topic. Well, then we need to address that other topic. So again, to me, this is a very important topic, and so we'll be, again, talking about it in a little more depth tonight. Some of the other topics that we did cover last night, talked about the fact that we can choose, tells us how we should choose. And again, the point there was if we did not have a soul, if God had not given us a soul, we could not make even a simple choice, because we would just be a chemical reaction. We would be several thousand trillion atoms chemically reacting, and chemical reactions don't make choices. So we could no longer make a simple choice. I was using the example of lifting up the remote. We could no more make a simple choice like that than a piece of wood could choose where it was going to burn in a fireplace if God had not given us a soul, because again, the wood's a sophisticated chemical reaction. If we were just like that, again, we'd have no ability to choose either. We talked about staying focused on eternity. One of the discussion topics was good is people are really busy today. I don't know if we're just busier now than we've always been, but there's just always things going on. If we have children, grandchildren, it just seems like there's always something going on. But our lives on Earth are really short. I mean, 100 years, most people would consider a very long physical life. 969 years, Methuselah, really long life. Both of those are zero compared to eternity. And so we need to really step back and see, well, what are we making ourselves busy with? Are those things really important? Are they going to be important for eternity, or are they only a physical benefit? And of course, eternity, by definition, is infinitely more important to stay focused on. Talked about God created time, therefore he cannot have a beginning or an end. That's related to eternity, but that's important also because that's a question that many people might ask. God made the universe, who made God? Well, by definition, because God not only made the heavens and the earth, but he also created time. In the beginning, God created. Then God could not have a beginning or an end. He has to be outside of time, where the words beginning or end don't make any sense. And so that answers that question. And that's one of the points we'll talk about a lot tonight. Is that's a question that the Big Bang can't answer without appealing to the supernatural, or the Big Bang theory, or any other atheistic theory. And so we'll talk about that some more tonight. Idea that life somehow made itself goes against true science. Again, God has given us the creativity and the intelligence to make cars and airplanes, space shuttles, amazingly sophisticated things. We can't make life from non-living material. No one's even come close. And so to say that life could just make itself, well, that's more absurd than saying a car or an airplane or a space shuttle could just make itself. Again, goes against everything we know about true science. Mutations and natural selection do not add information to the genome, and that's really what we're talking about, this idea that somehow that bacteria that we know couldn't make itself, but even if it did, how would it turn itself into all the other life that we see around us today? And that would require a tremendous amount of genetic information to be created, and we don't see that. Textbook examples of evolution either show nothing, or often they show the opposite of evolution, meaning they either show no new information, or many times they show information being lost. And so again, showing the opposite of evolution. Christians need to encourage our society to stay focused on the spiritual, and that's what we were talking about. Some of the recent, some countries around the world are now doing genetic screening of the mother of a pregnant woman, and then if they think that in the case that we examined last night, it was related to Down syndrome, but just for various reasons, sometimes putting tremendous pressure on the mother to kill her baby, and so that's starting to happen. And the only real way out of that is for us to really encourage society and keep focusing on the spiritual and not the physical. Belief in vestigial structures and junk DNA hindered true science. We talked just about that briefly, but this is the primary concern, of course, with religions that are opposed to God, opposed to the Bible, is the spiritual damage that they do, but they also do physical damage. And this was a case where true science was set back kind of by this commitment to false religions. And then also talk briefly about homologous structures. That was the idea that because we see similarities, physical similarities amongst life, somehow that might imply that one type of life or one kind of life turned into another. But physical similarities are exactly what we would expect, given that God created all life. And again, we need to focus on the spiritual difference because only people are created in the image and likeness of God. So I'm going to start out, again, talking about age of the universe, age of the earth. And I like the general idea that true science is the Christian's friend. And one of the ways to convey that is you just go back a few years and see what was the scientific accepted logic or accepted reasoning, and then see what happened as true science actually advanced. And so many times there would be these ideas, they'd be presented as scientific, and they'd be very opposed to the Bible, very opposed to Christianity. But then as science advanced, we showed that true science, again, always consistent with the Bible, always confirms the Bible. And so this was a case related to Mars. And at the end of 1907, when this was written, we're going into that time of year where you'll start picking up newspapers or magazines and always say, well, what were the biggest stories of the last 12 months? And so this is kind of like this is going on all the way back in 1907. Well, according to the Wall Street Journal, most extraordinary event of the past 12 months was the proof afforded by astronomical observations that conscious, intelligent human life exists upon the planet Mars. And you have to admit, that's pretty big. And so that was, so I can see why that would get the story of the year, the biggest news. And they had a lot of, scientific reasons. They had Percival Lowell. He was a Harvard University graduate, fellow of the American Academy of Arts and Sciences. He was very wealthy, and so he had actually sent a team, engineers and astronomers, to the Atacama Desert to observe the canals on Mars. Now that was kind of a clue. He sent the team to observe the canals on Mars rather than just sending a team to observe Mars and reporting back what they saw. So it's kind of getting a little bit skewed to start with. But anyway, they apparently, they came back and they had a pretty elaborate explanation, I guess, or elaborate imagination about these canals. And in conjunction, in parallel with this, the French Academy of Science and others are convinced that the Martian civilization was an established fact. Evolution was considered true. Life is expected to be common throughout the solar system and universe. And so when you see that picture on the upper left, well, these were some of the sketches about the canals, and in the middle, you're talking about and how these canals, they were taking water from the poles of Mars. We can see the ice caps, and you can see the ice caps on Mars through a kind of medium-sized telescope. And so had this whole elaborate explanation for all of these things that they thought they were seeing on Mars, and how, again, that was proof that there were humans on Mars. So as Christians, sometimes we're tempted to say, wow, that's fairly proven. I mean, what would we have done? I always like to think if you walk into work or you walk into college and someone plops that Wall Street Journal down in front of you, because they knew you were a Christian, and they say, well, what do you think about this? And so sometimes it's easy to try to give a response on the spot, and that's fine if we're sure. But I would just say, just in general, it's okay to say, "Wow, that's hadn't heard that before." Let me look into it more, and I'll get back to you tomorrow. Or it's never, unless we know the answer, it's never bad to say we need to look into things more. Because you think of a few of the responses we could have given. Well, maybe God also created men on Mars. Okay, so that'd be a thought. But then, why did Jesus come to Earth to die on the cross? Why they wouldn't have been descendants of Adam? See, kind of opens up a lot of spiritual issues. What if we'd said, well, maybe before the flood? Before the flood, we had 1,656 years of people that spoke the same language. They had better brains because they were closer to the original creation. They lived long. They could talk to each other. So, hey, maybe before the flood, people flew to Mars. You could say that one. Well, but then the issue would be, well, does that mean we can escape God's judgment? In other words, does that mean that if we're smart enough, we can get out of God's judgment? In this case, they escaped the flood by going to Mars. And so, again, there would be tempting to try to come up with an explanation on the spot, but it's a lot better a lot of times to just say, well, no, let's see how things play out. And we'll be talking about a lot of that tonight also. So this belief that higher life forms exist on Mars is really widespread through the 1950s. And on the left there, you see there was a Collier's front page story in 1954. Talks about is there life on Mars? Can we get to Mars? A lot of excitement about Mars. A lot of Disney films in the 50s. They're still available on YouTube, and it talks about. Someone will say things like, "Well, there's still the question: are we going to find a civilization on Mars, or is it just going to be like plants and animals?" So that was the two options, of course. And then, problem was, true science kept advancing. Mariner 4 in 1965 went to Mars as a probe, and wow, it looked like there was nothing there. Then we landed on Mars in the 70s, and then we got confirmation that, wow, there's nothing there. Right now, we have another rover on Mars. There's a helicopter flying on Mars. There's nothing there. It's actually, I shouldn't say nothing there. It's a really neat planet, but as far as, it has a lot of, elements, might be useful for eventual, outposts. So it's a very neat planet, but as far as life, as far as we can tell, there's nothing there. There's not even a bacteria there. And so that's, but she went from 1907, really probably till, I'd say like, at least 60 years, maybe 70 years before it became very obvious to everyone that, there's not only are there no humans on Mars, there's just no life at all on Mars. And so again, it's true science advancing always confirms the Bible is always consistent with the Bible. So that opens up a bigger question. I believe it was it's either in the 40s or 50s, Enrico Fermi made a statement, and he said, "Where are they?" Okay, so he's a very famous scientist, and what he meant by "where are they" is, again, the prevailing thinking there was that there should be, if evolution was true, there should be civilizations all over the place, and that's something that would have been predicted if evolution had been true, and we weren't seeing anything. And it wasn't for, even then we'd been looking very hard, and we had not seen any evidence that civilization. Well, this article was, or other civilizations, this article was published in June of 2018, and it was Oxford University study. And they're basically saying, they don't want to say they were wrong, because again, that's another case where evolution would predict something that ended up being completely falsified. But you read their statement, and essentially they're saying we were wrong. But it says, when we take account of realistic uncertainty replacing point estimates by probability distributions that reflect current scientific understanding, we find no reason to be highly confident that the galaxy or observable universe contains other civilizations, and thus no longer find our observations in conflict with our prior probabilities. So basically what they're saying is they guessed that there'd be a lot of civilizations out there. Observation said, no, there's nothing out there. And so rather than saying, well, we were wrong on our guess, they're saying, well, we're going to go back and adjust our guess, or adjust what we had predicted would be true. Goes on, we found qualitatively similar results through two different methods using the author's assessments of current scientific knowledge, bearing on key parameters, using the divergent estimates of these parameters in the astrobiology literature as a proxy for current scientific uncertainty. And then this was the punchline. It says, when we update this prior in light of the Fermi observation, which was again, where are they? We find a substantial probability that we are alone in our galaxy and perhaps even in our observable universe. And so if you look at those numbers, they're saying these are atheists, these aren't Christians. They're now saying just based on the true science, based on what we've observed. It's up to their opinion still, but up to a 99.6% chance that we're alone in the galaxy. Now compare that to what the thinking was in the 60s and 70s and even into the 80s, and that's huge. Because now they're essentially, again, admitting that people are unique, life is unique. And they say even in the observable universe, they're saying 85%, up to an 85% chance that we are alone. And so, that's, again, total shock to people that had put their faith in evolution, but it's very consistent with the Bible. Genesis 1:26-27 says, then God said, let us make man in our image according to our likeness, and let them rule over the fish of the sea and over the birds of the sky, and over the cattle and over all the earth, and over every creeping thing that creeps on the earth. God created man in his own image. In the image of God he created him, male and female he created them. So again, we all get to choose where we put our faith, but it's just interesting. True science, once again, is catching up with the Bible. Now, when we talk about our current knowledge of the universe, it's extremely limited. There have been ideas we talked a little bit about that last night, this idea that maybe if the universe was infinitely old, then somehow life could just make itself, or somehow evolution could happen. And so there's always been this push to try to make the universe as old as possible, to make the Earth as old as possible. But we started seeing problems with those theories really as early as 1933. And by the mid-1970s, evidence against these theories began to be publicized. And of course, the current most popular theory is the Big Bang, but it's basically these ideas that the universe just kind of exploded into existence. I think now they're saying 13.7, 13.8 billion years ago. There's some recent studies saying it's a few billion years less than that, but in that range, really a long time ago. But again, the evidence was started to pile up against those theories. And so in the mid-1970s, the evidence against the theories was so overwhelming that something had to be done. And I mentioned I've always been very interested in space. I even remember this. I was pretty young still, but there's actually this big controversy because the idea was it's not going to be a scientific theory if you have to add in what are essentially just fudge factors. In other words, make up some things that we put in to somehow avoid this fatal contradiction between what we observe and what the theory would predict. And the reason is it wasn't just 1% or 2% or some small fraction. We were going to have to make up 50% of the universe. Okay, so to make what's kind of turned into the Big Bang theory, but to make that work, we were going to have to make up 50% of the universe. We're going to have things like dark matter, dark energy. There's a lot of other entities that have been made up just to avoid this fatal contradiction. And so there's a big uproar. And you can see why, 50%. Well, the response was, we're going to start out with 50%. It's got to be 50%, but that's just kind of keep the framework in place. And then once we get more information, more observations, once we just get a little more data, that number will come down. Okay, well, you know what happened. The number didn't come down. It actually went up. And so now to avoid this fatal contradiction between what the Big Bang would predict and what we observe, we have to make up 96% of the universe. Okay, so just we'll talk quite a bit about that. But so right now, they have these theories, and of course they're publicly presented as, it's an established fact. Everybody knows that Big Bang happened. Well, you happen to make up 96% of the universe. I mean, is that really an established fact? So, a lot of different quotes on this. This was former NASA administrator Mike Griffin. Again, very hardworking individual. Very really, really smart. He was out talking about, basically a dinner speech. He's trying to justify, why do we do space exploration? And it's, I think the title was Space Exploration, Real Reasons and Acceptable Reasons. And it was the Quasar Award dinner where he's giving these comments. He said, what is the value of discovering that literally 95% of the universe consists of dark energy or dark matter, terms for things that we as yet know nothing about, but they make up 95% of our universe? Okay, and so it's interesting. We know nothing about them, but they make up 95% of our universe. Now, he was basically just saying, hey, one reason we need to explore the universe, explore space, is we don't know anything about it. And so I agree with that completely. But it's kind of interesting the way he phrased that. So I went ahead, I was working really late one night, so I went ahead and emailed him. And I'm thinking, what are the, I'm thinking he'll never even answer, he's NASA administrator, he's got tons of stuff on his mind. So it was probably about midnight I sent him this email. I start packing up, getting ready to go home, and literally before I even got my bag packed, he'd responded. Okay, and basically I just said, well, if we don't know anything about him, how do we know we make up 95% of the universe? And so exchanged several emails, but it really came down to, which he was completely accurate. The way he phrased it was, they have to make up 95% of the universe for the Big Bang to work. And if we're going to have faith, he didn't use those words, of course, but if we're going to have faith that the Big Bang works, then that's how we know that it makes up 95% of the universe. And so went back and forth quite a bit. And to my knowledge, want to continue the conversation, but again, to my knowledge, it's he's still committed to finding some type of a atheistic explanation for the origin of the universe. And again, want to stress, he's very intelligent, very hardworking, very moral person. And so it's just as an example of how these types of teachings or ideas, how they sink in or how they might affect people. We talk about other comments related to dark matter and dark energy. This is a quote from Scientific American. It says, dark energy considered even stranger. The only thing we know about dark energy is its name. Okay, so just think about that. So again, they're talking about, we don't know what dark matter or dark energy can be. We know they absolutely have to exist because they're required by the Big Bang. No idea what they could be. And so again, it's kind of ironic. They say the only thing we know about dark energy is its name. So again, just saying this is just, the stuff's just made up. So you go to other quotes. This is from University of California Observatory's Lick. And it just makes several points. I won't read the whole quote to you, but again, talks about, in this case, they're saying 74% dark energy, 22% dark matter. They talk about dark matter making up 85% of all matter in the universe. We don't actually know what it's composed of. Talks about how dark matter has to somehow clump together to make stars. And so we're just totally relying on things that again, we know nothing about, we can't observe, and that has to be 96% of the universe. Now, to their credit, they talk about, they use words like may, and they emphasize, they kind of imply that there's some doubt. A lot of the websites go out there and they'll say, no, this is just fact. Somehow this dark matter that we have no idea what it really is, it somehow all clumped together, and that's what gave us stars and galaxies and everything else. So we'll give, again, some websites are better than others. So where we're at right now is that dark matter and dark energy can be distributed out through the universe in any fashion desired. They have any property desired. There's a lot of different concepts. Dark flow and dark light are being mentioned, and I still have no idea what dark light is. I have to try to look into that more. But the whole point is a similar approach could be used to support virtually any theory imagined. And so, one of the comments had from last night is we didn't have enough math, and I should have realized that. A lot of times Friday night, Saturday night, people are in the mood for it. So I'm going to have a simple math equation on this next chart. But you think of the answer, but you're not allowed to use algebra. Okay, so we're going to keep it really simple. So the analogy is right now what we have is we have observations, so this is the true science, what we actually observe. Then we have all these fudge factors. We have dark matter, dark energy, dark flow, dark light, inflation, whatever else. And then we have a theory we want to support. Okay, so an analogy would be, okay, if x plus y equals 100, what does x equal? Okay, so can someone give me a number? That's true, yeah. Or you can even go -1. So I'll say -1. You're absolutely right. X is -1, y is 101. The answer is 100. Okay, I think I heard 25 over here. Okay, so you're right. Yeah, x is 25, y is 75. The answer is 100. Okay, say x is 60. Absolutely right. X is 60, y is 40. The answer is 100. Okay, so it doesn't matter. Your first response was right. Any number, it doesn't matter what x is. We can always come up with a y that makes that equation true. Now, suppose I come back next year and I say, hey, got some bad news. The answer is really 200. Does it matter? No. Say we went with -1. Yeah, x is -1, y is 201. The answer is 200. And so the way the Big Bang is configured, it doesn't matter what our observations are, because we can add fudge factors to pretend any set of observations supports any theory we want. And so we could pretend if a new theory is in vogue next year, yeah, we can take that same set of observations and pretend that they support that new theory. And so it's not a scientific theory. And so you think, well, okay, someone has a response to that. And it's always good to think, okay, what if someone still believes in the Big Bang, if that's where they've chosen to put their faith, well, how might they respond? Well, turns out there's actually a lot of non-Christians that have made this exact same observation. And so this was back in 2004. There was an open letter to the scientific community, and it was published in New Scientist. But it was signed by about 500 astronomers and professors, people working at national labs, scientists in general, just saying, making basically the same observation. Now they were a little more eloquent in how they phrased it, but I'll go ahead and read this to you, and it's still available out on the internet. It says, the Big Bang today relies on a growing number of hypothetical entities, things that we have never observed. Inflation, dark matter, dark energy are the most prominent examples. Without them, there would be a fatal contradiction between the observations made by astronomers and the predictions of the Big Bang theory. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. It would at the least raise serious questions about the validity of the underlying theory. So they're basically saying the same thing. No field of physics would, could you make up 96% of what you're pretending to explain? And then, of course, they gave dark matter, dark energy, inflation as prominent examples. It is funny, though. You got in the popular press, there's a magazine that actually published a map of dark matter. Okay, and it's glossy, it's a nice fold out, really, a lot of different colors on it. It looked really sharp. But you first look at it, you're like, well, how do you, if you can't observe dark matter, we don't even know what it is, how do you make a map of it? Well, what it actually was, it was a map of all of the places we had to add dark matter to keep there from being this fatal contradiction between what the Big Bang Theory would predict, and what we were observing. And so it was actually the opposite. What it was really showing was the exact opposite of what it was probably trying to show. It wasn't a map of dark matter, it was showing just how bad the Big Bang was, all these places that we'd had to stick dark matter. And so, but that's what, again, this is being pointed out by, astronomers, professors, other, various scientists in this field. Now, I'm not saying that they all have support the biblical alternatives, but they're just, a lot of them probably had their own atheistic theories they'd want to approach or be able to investigate. But it's just, again, showing what the state of the Big Bang is. It goes on and says, what is more, the Big Bang Theory can boast of no quantitative predictions that have subsequently been validated by observation. The successes claimed by the theory's supporters consist of its ability to retrospectively fit observations with a steadily increasing array of adjustable parameters, just as the old Earth-centered cosmology of Ptolemy needed layer upon layer of epicycles. Okay, so again, this is getting wow. What are they trying to say there? Well, it's actually, what they're getting at is the Greek philosopher Ptolemy had this idea that everything revolved around the Earth. And so we started getting observations, and you could observe the planets in particular, and you notice, well, no, it doesn't make sense. Things don't revolve around the Earth. Sun doesn't revolve around the Earth. Jupiter doesn't revolve around the Earth. Everything. But rather than saying, okay, I guess my theory was wrong, or his supporters at that point, rather than his supporters saying the theory was wrong, they started adding what they called epicycles. And so they would add these fudge factors to try to say, oh, no, Ptolemy was right. Everything revolves around the Earth. And so there's just these epicycles. And so what they're saying is we're doing the same thing with the Big Bang Theory. Long ago we should have said, hey, this isn't right. But instead of doing that, we just keep adding dark matter, dark energy, dark flow, dark light, inflation. We just try to keep propping it up, keep patching it up somehow. And so again, it's kind of a cleverly worded letter. So it's not just Christians that have noticed this. So then the question comes in, well, okay, what are some alternatives? And so these papers were published back in about 2009. One was a team of mathematicians, one was a team of physicists. Mathematicians said, this was published in the Proceedings of the National Academies of Science. It says mathematicians have come up with an answer Monday for the mystery of dark energy tearing the universe apart at an accelerating rate. It ain't there. Okay, so that's kind of the opposite of eloquent, but oh well. Okay, it ain't there. Blake Temple and Joel Smoller suggest that expanding waves from the Big Bang are propelling the trillions of galaxies. But the interesting part is right at the end, it says, or near the end, it says, dark energy is an illusion if their equations are right. However, the only problem is that for the equations to work, we must be literally at the center of the universe. Says physicist Lawrence Krauss of Arizona State University in Tempe. It doesn't seem physically relevant. Okay, so just think of what they just said. They have a way to get rid of dark energy, and so 73% of the universe right now has to be dark energy, which we have no idea what it could even be. Like Scientific American said, the only thing we know about dark energy is its name. They found a way to get rid of the need for dark energy, but it requires the Earth to be in a special location. So it doesn't seem physically relevant, okay, because we're in a special location. Now that was the mathematicians, physicists. Again, starts out, if Earth and its environs are centered in a vast billion light-year long bubble, relatively free of matter, and turns surrounded by a massive dense shell of material, then gravity's tug would cause galaxies inside the void to hurtle toward the spherical concentration of mass, say theorists Robert Caldwell of Dartmouth College and Albert Stebbins of the Fermi National Accelerator Lab in Batavia, Illinois. That process would mimic the action of dark energy. Okay, so wow. So if that's how the universe is structured, you don't need dark energy. Because it says a local observer would be tricked into thinking that the universe expansion is accelerating. The article goes on to note, but that scenario violates the Copernican Principle, a notion near and dear to the hearts of physicists and cosmologists, including Caldwell and Stebbins. Okay, so again, this could be like Nobel Prize winning material. We have no idea. So much we don't know about the universe. We'd had to make up dark energy. Dark energy has to be 73% of the universe. Team of mathematicians, team of physicists say, hey, if this is the scenario, you don't need dark energy anymore. Huge breakthrough, but they're told it can't be physically relevant. Okay, and so I mentioned the Copernican Principle. Well, Copernicus, again, must be scientific. Anybody know what Copernican Principle is? It scientific or religious? Yeah, 100% religious. Yeah, what it's really saying is we're committed to atheism, and if the Earth is any place special, that might imply the existence of God, so we're not allowed to consider that. Okay, so think of just how big of a setback the Copernican Principle is to our understanding of the universe, because you kind of have the obvious answer. I had to make up dark energy. It has to be 73% of the universe, or I can say the Earth's at a special location and get rid of that. But we're not even allowed to consider that the Earth might be at a special location, because at least in the mind of the atheists, that could that's just a little too close to implying the existence of God. And so again, a huge setback for cosmology, but again, it's now the Bible doesn't say that where God put the Earth. The Bible doesn't say that God put the Earth at the center of the universe, but the Bible is written to people. Jesus did come to Earth to die for our sins, and so it's certainly not it's not inconsistent that the Earth would be at the center of the universe. If the Earth is at the center of the universe, you eliminate the need for dark energy. So that's, again, it's interesting, again, just, talk about true science is the Christian's friend, but false religions also really hinder true science, because as was noted by both the team of mathematicians and the team of physicists, they weren't even going to pursue that line of thinking because it would basically violate was apparently a fundamental tenet of atheism. I'd almost like to go convince them that, hey, I won't even go there. I can't figure out why they're so hung up on that, because the fact that they've just admitted that we're probably the only civilization in the universe, then why would, it seem like they could tie the two together and say, well, maybe, I don't know, just seems like they could tie the two together somehow. So we at least be allowed to do true science or pursue the science the way the observations are leading us. And so then what's interesting is that then starts answering some potential questions also, because if that scenario is true, and I'm going to be using ifs a lot because the Bible doesn't tell us exactly where God put the earth. But if God did put us there near the center, then there's biblically consistent theories that explain how the universe appears the way it does from an earth that's a few thousand years old. And so it has to do, it's kind of pushing our knowledge of physics, which is one of the things that makes me nervous, because a lot of times if we're pushing our knowledge, then at that point is it for sure right? But this is based on Einstein's general theory of relativity. It's talking about gravitational time dilation. We have observed gravitational time dilation. And so if we imply that and we're near the center of the universe, then you could have the universe developing while literally zero time is passing on Earth. And that because we're in what's called a timeless zone inside the event horizon of a large black hole. And so then on day 4, when it talks about, God made the stars, well, that would be on Earth's day 4. Bible's written to Earth, Bible's written to people on Earth. We know time, time is different depending on where we are in a gravity well. All these things that we're just starting to understand about physics. So again, it's very biblically consistent, but it would gives that explanation, because a lot of people, sometimes you hear the question, well, how do we see light from stars that are millions of light years away? Implying if the Earth's really less than 10,000 years old, how do you see light from stars that are millions of light years away? Well, this would be one explanation. And so again, it's not, it's getting in more detail. I'm going back to, okay, if this is the equivalent of 1907, and we're just starting to figure out, 1907, we're just starting to figure out things about Mars. Now hopefully we'll be allowed to. We're starting to figure out things about the universe. But, just have to see how this one plays out. But it's much better because you don't need dark energy. So it's better than the leading atheistic theory. And it's, it's just, very biblically consistent on many levels. But you also have other ideas that are put forth. What could stretch out the heavens imply? Something like, I think it's 17 times in the Bible. Bible talks about God stretching out the heavens. So that's, possibly stretching the actual fabric of space. What does that do? A lot of people are guessing. Some people say they think they know what would happen if we actually stretch space, but I think most people are still, that's things that we're still trying to understand what the implications would be. Could that change decay rates? Could that change the energy released per decay? Could that change, what all factors could that possibly change? What if God chose to make parts of creation mature? We know God made parts of creation mature. Adam and Eve were created as adults. And the question is just what all parts could God have made mature? And so that's another area that people pursue. And then of course we're going to have new discoveries also. But again, I'll just go back to, it's not just the spiritual damage of atheism. Just think about that. There's a whole line of evidence related to cosmology that we're not pursuing, and it eliminates this huge fudge factor. It eliminates the need for dark energy. Not allowed to pursue that because, in some people's opinion, that somehow implies God because we're in a special location. And so it's both the physical damage to our physical understanding as well as spiritual damage. The other one is, this is more of those ones, where things that some people will pound the fist on the table and say is a fact. Others will say, well, actually we don't know that much about it. And so this was kind of ironic. I think it's might even still be out there. There's a Wikipedia article that says, it essentially says we know the age of the universe to 5 significant digits. Okay, and then this was so I just checked to make sure it's still there when this particular article came out. This was a couple years ago. AP said, the universe is looking younger every day, it seems. New calculations suggest the universe could be a couple billion years younger than scientists now estimate, and even younger than suggested by 2 other calculations published this year that trimmed hundreds of millions of years from age. So it's not, those ages are still much longer than they're much more than 10,000 years, but the whole point is, on the one hand, you'll have people just insisting, we know, established fact, and here's how he did it, and then you'll have other, equally credentialed scientists saying, no, we're off by billions of years, and then they'll have good reasons for that. So again, it's fun to watch, and it's not, and we should just view it almost as fun to watch until it starts affecting someone's faith. Because if any of these areas really start affecting someone's faith, and they say, well, science has somehow proven the Bible's wrong, that's when it becomes important. And so that's, again, a lot of, because a lot of people that are interested in science and engineering, this can become a stumbling block to them. And so just some thoughts. Now again, though, going back to the Big Bang, there's always a question of, well, what was there before the alleged Big Bang? And all the explanations are metaphysical. As we mentioned last night, two of the more popular ones were that, well, the Big Bang exploded from a point of infinite density where the laws of nature don't apply. Well, if the laws of nature don't apply, then you're supernatural. That's supernatural explanation. Recently, they talk about having universe generators outside the observable universe, in other words, outside of nature, that have just created an infinite number of universes. Well, it's outside of nature. So again, it's an appeal to the supernatural. And so, but looking at things comprehensively, that point of infinite density, that universe generator, well, it can't give us free will. And we know we have free will. And so if we look at the big picture, again, the Bible gives the comprehensive picture of the creation of the universe, the creation of the earth, the creation of life, the creation of you and me, and God sending his son to die on a cross so we could be forgiven of our sins. So again, it's concise, but again, the Bible is a much more consistent explanation, and true science is always catching up with the Bible. The final one on the Big Bang, and then we'll move into some of the radiometric dating techniques. Okay, so this is a really strange one, and when someone first told me about it, I actually had to go look it up. It's like, people don't really believe this, and so, but what it turns out is, if universes can randomly pop into existence, then there's a much, much greater chance that just a brain would pop into existence. Okay, so you think of a universe as finely tuned as our universe, just somehow popping into existence. Much more likely that just a brain would pop into existence. Now, if a person doesn't think we have a soul, which again, it would imply they don't think we have free will, but if they don't think we have a soul, then all they have to do is just look at basically the atoms in our brain and say, okay, what would be the odds of a brain, with that exact configuration popping into existence? And again, they conclude that that'd be much higher than the odds of a universe popping into existence. So they call it the Boltzmann brain problem. And I'll just read this. This was, I think this was from Wikipedia. It says, if our current level of organization, having many self-aware entities, is a result of a random fluctuation, is much less likely than a level of organization which only creates standalone self-aware entities. Okay, so in other words, it's saying, the universe, it's much less likely the universe would form than just standalone, basically brains popping into existence. For every universe with the level of organization we see, there should be an enormous number of lone Boltzmann brains floating around in unorganized environments. In an infinite universe, the number of self-aware brains that spontaneously and randomly form out of the chaos, complete with memories of a life like ours, should vastly outnumber the brains evolved from an inconceivably rare local fluctuation the size of the observable universe. Okay, so again, it actually is, I was going to say that's stranger than science fiction. It actually is, derivatives of that are in a lot of science fiction movies now. But what they're really saying is, I'll use myself, from my perspective, you guys aren't really here. This building isn't really here. I didn't just have some great barbecue with a couple of your elders. None of that. That was just all that's just all my brain, these chemicals that just popped out of the chaos for a tiny, tiny fraction of a second. That's just how they're all wired. And then I'm going to dissolve into the chaos in a tiny, tiny fraction of a second, and that'll be it. That's what it's saying. And there's actually money being spent now trying to resolve the Boltzmann brain problem. Okay, and so all I'll say is that's, we all get to choose where we put our faith, but also just the degree to which people, or even, unfortunately, whole societies will go to try to deny God. And so it's literally to the point that people are even talking about things like Boltzmann brains. And so so on the Big Bang, I think probably the biggest one is, to me at least, is, hey, we're having to make up 96% of the universe, and other things too. Inflation really isn't part of the current universe. We have no idea what caused inflation, what would have stopped inflation. It turns out, we're having to constantly tweak it. So it's another fudge factor. You have all these different factors. So Big Bang's not even a scientific theory. So if someone tries to say, oh, that's a scientific theory, it's not. I mean, again, any theory where you have to make up 96% of what you're pretending you're going to explain, and then maybe point out the idea that with that approach, it doesn't matter what our observations are or what the theory is. We can just add fudge factors to pretend any set of observations support any theory we want. There are biblically consistent theories that are better. Also, the Big Bang always has to appeal to the supernatural, and so it's really not a purely naturalistic theory, no matter what. And then finally, just some of the kind of the more absurd, implications of the Big Bang, with of course Boltzmann brains being one of them. So that's kind of discussion on the Big Bang. Again, true science is the Christian's friend. In the beginning, God created the heavens and the earth, and the heavens declare the glory of God, and the firmament show His handiwork. Okay, so now I want to move into radiometric dating, and divided that into two sections. The first one, I'm going to talk about carbon dating, and the second one, we're going to talk about some of the radiometric dating methods that are used to claim very old ages for the Earth. And so, and the reason I divided it into two is with carbon dating, it's typically only used, back for I guess you say like relatively recent artifacts. So say if someone finds a wooden bowl or something containing wood, some kind of an artifact, and that's because carbon-14, which is used in carbon dating, has a half-life of 5,730 years. So it would go away, should go away, very quickly relative to what some of the claimed ages of the Earth are. And actually the fact that we still find carbon-14 in coal and diamonds and fossils is a very powerful indicator, that the Earth is very young, just because of that 5,730 years. And I always tell people, 6,000 years is actually really old. I don't know anybody that old, but it's still considered, for whatever reason, considered young. And so, I'm going to talk some about that on the carbon dating. And then the other forms of radiometric dating, those are usually used to claim much older ages, billions of years, and that's just because of the half-life of the isotopes that are involved. And so, I want to start out just pointing out, most dating methods indicate the Earth is a few thousand years old. If we look at the amount of sediment on the seafloor, there's very little sediment on the seafloor, and we can look at how fast sediment is being added to the seafloor just by erosion. And then we can estimate fairly well how much sediment is being removed via plate tectonics. And if we look at that balance, we find there's very little sediment on the seafloor. And if we take into account the effects of the flood, it's very consistent, again, with the Earth being a few thousand years old. You have bent rock layers, and have some graphics probably won't be able to get to tonight, maybe tomorrow morning. But you have bent rock layers. You have these huge layers of rock, but they bend. And right now, those rocks, they're brittle, and so if you look at that rock, it'll just crumble between your fingers if you take a piece of it. But you look at those bends, there's no cracks in the bend. And so if you had this theory that, these layers of sediment were laid down over many, long periods of time, millions of years or whatever, it would have dried, and, would have been flat. And so one of the ideas is, what if you had this uplift? So maybe part of the rock lifted up and the other part, came down, and that caused this bend. Well, if that happened, it had to happen shortly after those sedimentary layers were laid down. Otherwise, you would have seen cracks. You don't see cracks in the bend, just a totally smooth bend. It's very brittle. It'd be like saying you find a coffee cup, and then someone saying, "Oh yeah, after the ceramic had been fired, we bent that coffee cup into the shape of the coffee cup." And it's like, no, it had to be formed while it was still soft. And so the bent rock layers are again, very consistent with the Earth being a few thousand years old. The rock layers essentially laid down during the flood, and then any distortion occurring at that time or very shortly thereafter. Soft tissue in fossils. When I was growing up, it was always, the reason you'll never find, essentially soft tissue in dinosaur bones is they're 65 million years old. Well, about 15 years ago, these were evolutionists. They started finding soft tissue in dinosaur bones, and now we routinely find all kinds of different, essentially soft tissue in dinosaur bones. You section the dinosaur bone. And so, again, that's very consistent with those bones being a few thousand years old. Really, really hard to explain how they could possibly be whatever the current idea is, 65 million, 68 million years old. Rapidly decaying magnetic field, the total energy in the Earth's magnetic field appears to be decaying on an exponential. And we have direct measurements back about 150 years and pretty good idea of what's been going on for at least the last 1,000 years. And so that's the total energy in the Earth's magnetic field. And so that would be if you had a magnetic field at creation and then a standard exponential decay that we see in situations like that, it'd be very consistent with that scenario. But it also limits the age of the Earth, the absolute maximum age of the Earth, to maybe 20,000 years. Doesn't mean the Earth couldn't be less than that, just that would limit, because then the field strength would just be too strong at the time of creation. You have helium and radioactive rocks, and we will talk about this some tonight. Essentially, when you have uranium, say uranium-238 decaying to lead-206, you end up producing 8 helium nuclei during that decay process. It's called alpha decay, and alpha particles, basically a helium nucleus. And so, but you can look at then the amount of uranium that was estimated to turn into lead, U-238 decaying to lead-206, and then you can measure, though, the diffusion rate of helium out of that particular mineral. So they're usually crystals. A lot of times we'll hear about zircons. And you can go in the lab, true science, you can measure the diffusion rate of the helium out of that zircon. And so what we find is, with the assumptions we're making, and there are other assumptions involved, one of it is that just there was no lead to start with, it was all uranium. But with the assumptions, if you look at the ratio of the uranium to the lead, you figure out how much helium was produced, and you find out, okay, this amount of uranium turned into lead, and you can use one set of assumptions to get, okay, this is the age of the zircon. But then you can also say how much helium is still in that zircon. And by measuring that, you have another estimate on age. And so that's, so two ways you can look at that. So that's, when you put those two together, again, it's very consistent with a lot of radioactive decay, but happening recently. And so that's, again, consistent with the Earth being, on the order of, less than 10,000 years old. Carbon-14 in fossils, coal, and diamonds. Again, mentioned that half of the carbon-14 goes away every 5,730 years, but we still find carbon-14 in coal that's supposed to be 300 million years old, diamonds that are supposed to be 1 billion years old. We still find carbon-14 there. And we rule out contamination, you use the best available equipment. So the fact that there's still carbon-14 in those samples, they can't be that old. Because, it's kind of that, I don't know if you ever heard that analogy, like if I said, I'll give you a penny now, 2 pennies tomorrow, 4 pennies the next day, 8 pennies the next day, 16 pennies the next day. I'll do that for 2 months. Or I'll give you $100 right now. Which one would you take? Pennies, good. Okay, so I like pennies because that means you actually trust me. If you didn't trust me, you'd say, take the $100, just take the money. But anyway, but you're absolutely right. The pennies you'd end up with, I think it's like all the wealth of the entire world after 2 months. And so that's, so just think of that, it's kind of in reverse. If half of it goes away every 5,730 years, turns out something like if the entire Earth was made of carbon-14 atoms, you wouldn't even make it to 1 million years before there were no carbon-14, no Earth. Basically every single one of those atoms would have decayed away. And so that's so again, that's carbon-14 in fossils, coal, and diamonds. Very again, very consistent with the Earth being a few thousand years old. Very little salt in the sea. Again, it's just looking at the rate that salt's being added to the sea, and then any mechanisms for removing that salt. Again, taking into account some of the flood, effects of the flood. And then DNA in ancient bacteria. That's a real conundrum because we find out DNA in ancient bacteria, what's called ancient bacteria, supposedly sometimes they'll claim over 100 million years old, basically the same as DNA today. And so, well, how would that DNA last that long? And oh, by the way, even if it did somehow, why is it still the same? When evolution has said that the bacteria that weren't preserved would have evolved during that time. And so, so anyway, the last major discrepancy, I'd say, was radiometric dating. And so different isotopes typically used in radiometric dating, depending on the sample. As the name implies, carbon dating is used when the sample contains an adequate amount of carbon, but radiometric dating is also based on decay of potassium-40 to argon-40, decay of uranium-238 to lead-206, decay of rubidium-87 to strontium-87, decay of samarium-147 to neodymium-143, other decay chains. And so again, that's why kind of breaking this into sections. So with radiocarbon dating, and going to have to, we'll go at the right pace. Okay, I was going to say, I was asked at dinner about how long should the talk tonight be, and I said 5, maybe 6 hours, but we'll get through it. So anyway, we'll finish up on time. So with radiocarbon dating, Essentially what happens is you have carbon-14 formed in the atmosphere by cosmic rays interacting with the atmosphere. So you have a cosmic ray, you can think it interacts with the atmosphere. Well, occasionally it will kick off a neutron, and that neutron will slow down, and then that neutron can have a nuclear reaction with nitrogen. So nitrogen is just nitrogen-14. And it has a reaction that's called an NP reaction. So basically the neutron gets absorbed in the nitrogen-14, a proton gets kicked out, and that's a carbon-14. So that carbon-14 that's radioactive. It has a 5,730 year half-life. Current half-life is 5,730 years. And so the idea is that's all happening. And so right now, about 1 out of every 1.2 trillion carbon atoms is a carbon-14 atom. And so just to make the math easier, we'll say there's 1 out of every trillion atoms is carbon-14. So this desk was made fairly recently, this podium. And so we assume that the ratio of the carbon-14 to carbon in this podium would also be 1 in a trillion when it was made. Probably good assumption. We could actually measure it right now. Well, if we came back here in 5,730 years, it would be down to 1 in 2 trillion, because half of the carbon-14 would have decayed, the stable carbon would still be there. Came back in another 5,730 years, it'd be 1 in 4 trillion. Came back 5,730 years after that, it'd be 1 in 8 trillion. And so it keeps cutting in half every 5,730 years. And so, as you can see, if we know the ratio of carbon-14 to carbon at the time that, in this case, this podium was made, then that would be, a way, assuming the decay rate stays constant, that would be a way that we could estimate, age, down the future, how long ago this particular podium was made. Now so again, I think we just talked about this again. The idea, the reason is that carbon-14 to carbon ratio, anything, plants and trees, as they're taking in carbon from the environment, that's the ratio that gets incorporated into the plant or the tree. But what's important to mention and remember is the actual measurement is just the current ratio of carbon-14 to carbon. And so if we take a sample and we send it to a lab and it measures, carbon-14 to carbon ratio, and they're very good at those measurements. These accelerator mass spectrometers, very accurate. So it's not the accuracy of the measuring equipment. It's just we have to remember what are they actually measuring. They're not measuring the age. They're just measuring this ratio of carbon-14 to carbon. And so all of the discrepancy and basically all of the dating, that comes from what assumptions are applied to that. So that's why we had the title, Assumptions in the Age of the Universe, or Assumptions in the Age of the Earth. And so this is just an example. Won't go through this a lot. This was, again, just the point being that there's very precise equations, and they're not nearly as bad as they look. And it's just a way that you could estimate the, based on the current concentration, which would be the C naught, which would just be the concentration at the time of death, like whenever the tree was cut down to make this podium. And it's just, equals, so C equals C naught, and then e to the negative lambda t, and that's just, T is time, and then lambda is the essentially 0.6931 divided by the half-life carbon. It looks scary, they're not. So you always use the same equation, but it's all the assumptions that come into play. So in this case, suppose the initial concentration is 2% of the atmospheric concentration today, and we make these uniformitarian assumptions, you can run through the numbers, and you end up with a T of 32,330 years. Okay, so that's one, using that equation, again, and just running through numbers, but that's assuming, kind of like we were warned in, the people will, basically assume things are all the same, the way they've always been. We're told that people deny the effect of the flood, they'll deny the effect of creation. We end up with, and so that's a non-biblical date. But if you go ahead and you assume the, again, you have the concentration of samples, 2% of a certain concentration today, but if you take into account the effects of the flood, for example, with, again, assuming, say a lot of the carbon that's trapped in coal and oil and natural gas was buried during the flood. If you start taking into account the effects of like the different CO2 solubility in seawater, depending on the temperatures of the oceans, I mean, you have huge effects. That C naught ratio, that ratio of, when an artifact, the C14 to carbon, say in an artifact that was made shortly after the flood, that can change easily by a factor of 200, just based on the amount of carbon in the biosphere at those different times. So if you take that into account, say in this case, we just assumed that the C0 was 1/30th of today's atmospheric C14 concentration, same exact equation, same measurement, same lab, you end up with a time of 4,210 years, which is actually pretty biblically consistent with some of the civilizations that popped up right after the Tower of Babel. So again, just want to emphasize, same equation, same measurement, but in this case, it's the assumption of what was the C0 to C ratio, or basically what's the carbon-14 to carbon ratio at the time the sample was formed. And in this case, and so what you find then is that the carbon dating works pretty well until you get to within a few centuries of the flood. And then that's when you would expect it to fall apart, because more than a few centuries after the flood, things would tend to stabilize, they'd equilibrate it again. But if you go back beyond that, that's when you expect to see discrepancies, which it appears to be the case. So then you have other discussion points. We talked about C14 and coal and diamonds. That can't be if they were really millions of years old. Of course, the Bible doesn't tell us how much C14 was originally in the earth. How is it distributed? Again, if the Earth's on the order of 6,000 years old and you have an isotope with a 5,730-year half-life, that actually makes a huge difference. And so we don't know. What if radioactive decay rates were accelerated in the past? We'll talk about that a little bit in the next section. What if the cosmic ray flux or spectrum was different in the past? Okay, so it gets even more interesting. Say the solar activity during solar maximum, you actually have less cosmic ray flux hitting the Earth than during solar minimum, and it's by a fairly significant amount. And so remember, the cosmic rays hitting the Earth are what cause the interaction in the atmosphere that creates the neutrons that then causes the nitrogen 14 to convert to carbon 14, which says this ratio. So it's there's just a lot that goes into that. If any of those are different, then again, you're going to be changing this carbon-14 to carbon ratio. Talked a little bit about carbon dioxide concentration in air were different in the past, so most scientists predict much higher concentration prior to the formation of coal, oil, and natural gas deposits. And again, there's huge differences between when, if the coal, oil, and natural gas was formed primarily in the flood versus the idea that maybe they were formed over just, many, many eons of time. And so you have, that's a difference. But there is agreement that before coal, oil, and natural gas was formed, there's been a lot more CO2 in the air, and that could, again, lessen this ratio of C14 to carbon, which would make things appear older than they really were, especially when you get back close to the flood. And then, of course, again, CO2 being released by oceans warmed during the flood. It also could have a very significant effect. You can look at, there really aren't any explanations. They talk about radioactive decay, of uranium, thorium, but you run the numbers on that, and it's you can't even theoretically make that amount of anywhere close to the required amount of carbon 14 to be. Basically, you can't make it happen unless you have these incredibly accelerated radioactive decay rates. But you still can't get the required amount of carbon 14 to somehow say that it's being formed in situ. But even if you could generate that amount of carbon 14, even with vastly accelerated decay rates, it doesn't put it in the right place. You don't end up getting carbon 14 in diamonds. You don't get the carbon 14 where you wanted to get. And so this was just a slide just pointing out there are people that try to explain this. But again, there's no explanation other than those samples have to be much younger than what they're often said to be. Then some people say, well, can archaeology be used to calibrate carbon dating? And so, in other words, sometimes we'll say, well, we estimate this certain city is a certain age, and the statement will be made, well, we didn't use carbon dating. What we did is we looked at how many layers there were, or what was the pottery style in the layers, or what kind amount of residue was on the pottery. So didn't use carbon dating. But then you look into all those assumptions, you start saying, well, what inherently about a certain number of layers would tell us how old a city was or how old some ruins were? Well, there's nothing inherent about that. It just depends on, well, how fast were those layers formed. And so when you get to the bottom of it, it's always calibrated back to carbon 14. Sometimes you use tree ring dating, but even the tree ring dating is often calibrated to carbon 14. And so I'll give an example. Say this this remote again. Say I send it out to a lab and ask them, okay, measure how long is that remote? And the lab comes back and says, well, it's 100 feet long. Okay, so I say, okay, great. So now my remote's 100 feet long, and so now I'm going to measure your podium up here, and so there's 100, 200, 300, 400, 500, 600. So I say, wow, so this is 100 feet long, and so I know that the podium at the Royal Oak Church of Christ, it's 1,000 feet wide, huge, and then I could say, well, how big is the auditorium? Well, if I could, I could take this podium and I could stack it across, and wow, you'd have like several mile wide auditorium. And then if someone said, well, was your auditorium measured using the remote? And I'd say, no, it wasn't measured using the remote, it was measured using podium lengths, okay? But still, the whole thing was, though, the reason I got the erroneous estimate for the auditorium was because ultimately that dimension was based on the length of this remote. So if the carbon-14 dating is wrong, especially when you get back close to the time of the flood, where there's going to be a lot of variations in this carbon-14 to carbon ratio. Again, we have to take into account effects of the flood, but that's biblically consistent. And we're even warned against that people will ignore the flood, just pretend it never happened, say things are always the same as they've always been. So again, it's if those estimates are based on carbon dating, then the estimates that are supposedly derived are just from how many layers deep is something buried, or what's this pottery style, those are also going to be wrong. And so again, archaeology can't be used to calibrate carbon dating, essentially the opposite has occurred. Other discussion points, you can look at other isotopes, beryllium-10, chlorine-36 are sometimes looked at, but again, you have the same types of assumptions and the same sensitivities for those isotopes as well. So again, advances in true science shown radiocarbon dating to be fully consistent with the Bible, but again, we have to take into account reasonable effects of the flood. If we make uniformitarian assumptions, assume everything's been the same for millions of years, then we'll see, carbon-14 is inconsistent with the Bible. But again, it's not biblical. We need to take into account the recent creation and the effects of the flood. Genesis 1:31, then God saw everything that he had made, and indeed it was very good. So the evening and the morning were the sixth day. And then Exodus 20:11, for in 6 days the Lord made the heavens and the earth, the sea and all that is in them, and rested the seventh day. Okay, so last topic I'm going to talk about is the age of the earth. So we kind of talked a little bit about, kind of related to age of the universe when we're talking about the Big Bang. We talked about some of the ages where people will say, I found this piece of pottery, or found this, some biblically inconsistent date. But when you talk about the age of the earth, that's one, again, where right now I think some people are saying like 4.54 billion years, but it's solely based on radiometric dating and the assumptions that are made with that radiometric dating. As we talked about at the start of this section, most ways of estimating the age of the earth are very consistent with the earth being less than 10,000 years old. So this is a quote from Carl Sagan. This is Communication with Extraterrestrial Intelligence, MIT Press, back in 1973. Again, I know we're covering a lot at the same time, but just wanting to tie some of this together. Communication with Extraterrestrial Intelligence. This was a theme back in 1973. Again, in 2018, okay, so that was how many years later, they're saying, hey, there's up to 99.5% chance we're alone in the galaxy. So just think of how much in 45 years, how much things changed, or coming up close to 50 years, how much, or I guess that would be 45 years then, how fast, how much things have changed. So anyway, that was the title of his book. So this is Carl Sagan. He says, well, it is clear that one could randomly assemble all the elementary particles in the universe 1 billion times a second for the age of the universe and never get this protein. And so he had just talked about just the odds of a protein randomly forming itself was 1 in 10 to the 130th power. Now this was it was like an interview. So I don't know if he caught himself or he just didn't see the irony, because in the book it's on the exact same page. Okay, so he just said, again, randomly assemble all the elementary particles in the universe 1 billion times a second for the age of the universe, never get this protein. A few sentences later, he says, there is no doubt about the fact of evolution. Okay, so again, we all get to choose where we put our faith. he'd obviously, unfortunately, chosen to put his faith in evolution, put his faith in atheism. But there are still sizable questions on the mechanics of the evolutionary process. So he basically just said, hey, this is impossible, but there's no doubt that it's true. And it's a really kind of an ironic statement. So, but anyway, there is this push to try to make the Earth as old as possible. So with radiometric dating, there's 3 assumptions that have to be made. First is the degree to which radioactive decay rates have fluctuated throughout the life of the sample being dated, and that's typically assumed to be 0. Okay, so there's no fluctuation in the radioactive decay rates throughout the life of the sample. Original concentrations of the isotopes being used to date the sample, and the addition or subtraction of isotopes being used to date the sample throughout the life of the sample. And so, the one I'm going to talk the most about, and again, want to stress, is the Bible isn't explicit about this, but one that's really shown up probably about the last 15 years ago is the fluctuations we're observing in radioactive decay rates. And so I'll focus on changes in decay rates during creation week and the flood. That could have a significant effect on the estimated age. And so it was about 2006, and then I did a little more research. It turned out really back even into the 1990s, people were reporting fluctuating radioactive decay rates. Okay, and so this was Stanford and Purdue, and I'll give a few of the quotes. I think they were amongst the first to report it, but Ohio State, pretty close to here, has reported some. Research institutes in Germany and the U.S. have reported some. And so they started publicizing these fluctuating decay rates because it's not supposed to happen. The decay rates are supposed to be totally constant, and all of our radiometric dating is based on the assumption that the decay rates are totally constant. And so it's kind of interesting. A lot of the articles, they'll even say, well, but the fluctuations are so small they don't affect our radiometric dating, our radioactive, basically dating based on radiometric decay. And they're right. Today, they're very small fluctuations, but they are there, and they're statistically significant. We have no idea what's causing them. Okay, and so again, that's kind of beyond our scientific understanding. But the fact that today, when we look out and things are relatively stable, we're seeing these fluctuations, and we don't understand what's causing them again, but to think that, well, they're fluctuating today when things are physically stable, what could have been happening during creation week, or what could have been happening during the flood? So I'm never going to be able to go back to the flood, and measure decay rates. I'm never going to be able to go back to creation week and measure decay rates. But again, just the fact that they're fluctuating now could have had, it's not unreasonable to think that, well, when things were much less physically stable, again during creation week and the flood, that they could have been fluctuating much more. And so changes in decay rates could fully explain potential discrepancies between radiometric dating and the biblical account. And it also explain the discrepancies between the radiometric dating methods and the other methods that we have for estimating the age of the Earth. And so again, it's going to be, to me, it's like 1907 when we're trying to figure out if there's humans on Mars. Okay, well, it's 2021 and we're trying to figure out, okay, what's causing radioactive decay rates to fluctuate. So this was some quotes. This was Popular Science in 2010. I was quoting from a published article. It says, the sun at 93 million miles away appears to be influencing the decay of radioactive elements inside the Earth, researchers say. Study by Stanford and Purdue scientists found that the core of the sun, where nuclear reactions produce neutrinos, spins more slowly than the surface. This phenomenon might explain changing rates of radioactive decay scientists observed at 2 separate labs, but does not explain why the decay change happens. That violates the laws of physics as we know them. The article asks, how could the nebulous neutrino, which does not interact with normal matter, be affecting decay rates? No one knows. It might be a previously unknown particle instead. And so I actually like that when they, the violates the laws of physics as we know them. And so I like that for 2 reasons. One, of course, is just makes science exciting, because now, okay, there's still stuff to discover. And then the second one is also if we don't figure out some physics, and God created the universe and the physics is there, we just haven't figured it out yet, then we're kind of stuck. I mean, and Earth's a great place to be stuck, but it's going to be really hard with our current understanding of physics to really get much beyond Mars, at least with people. And so I really hope that there's stuff about physics we don't understand. That's why one of the reasons it's so important we're allowed to actually pursue true science. Going back a few minutes, that's why it's so important. If all the observations say we're near the center of the universe, let's develop our cosmology, at least develop a cosmology that takes that into account. And so the same thing, if we're seeing decay rates fluctuating, and we have the biblical account, and we can learn a lot from the Bible, what the Bible says about history, start piecing that together, so we can figure out what is the physics going on here, what is actually happening, because there is actually a lot of things that we could piece together and try to start investigating. So again, violates the laws of physics as we know them, and then the other point again to be made is if what we think we know ends up being false, but it's been used to challenge people's faith, that is really important. One of the things we'll talk about tomorrow would be some of the, you'd say like fossils that were misinterpreted and somehow spun to say that, well, maybe, to somehow, show apes turning into humans. So you always wonder, and they ended up being totally false. They figured out, basically more science advanced, found more bones. But you wonder how many people were led astray. How many people lost their faith because of something that someone, said they knew, but again, it ended up being false. But again, it led them astray. So this is a case here. Could be Stanford University in 2016. So this is the professor emeritus of physics at Stanford. So what's good is you have some very, I actually don't know if he's an atheist or a Christian. He is very credentialed, obviously scientifically. It says the research that Sturrock learned about in Tucson concerned fluctuations in the rate of decay of radioactive elements. The fluctuations were highly controversial at the time because it had been thought that the decay rate of any radioactive element was constant. Sturrock decided to study these experimental results using analytical techniques that he and Scarl had developed to study neutrinos. And so this is, articles released by Stanford University. Goes on, says, in examining the radioactive decay fluctuations, the team found evidence that those fluctuations matched patterns they had found in the Super Kamiokande neutrino data, each indicating 1 month oscillation true to solar rotation. The likely conclusions in neutrinos from some are directly affecting beta decays. This connection has been theorized by other researchers dating back 25 years, but the Sturrock-Fishback-Scargill analysis has the strongest evidence yet. If this relationship holds, a revolution in neutrino research could be underway. So he's actually trying to patent neutrino detectors based on, or do neutrino research based on this phenomena. Maybe trying to be able to predict solar flares. And so what's good about that is that there's an application now, people looking at fluctuating radioactive decay rates to do other things with. Because once there's an application, then there tends to be more research money available, more things that can be, basically more investigation than will be allowed. And then just another article, this was Astroparticle Physics, says additional experimental evidence is presented in support of the recent hypothesis that a possible solar influence could explain fluctuations observed in the measured decay rates of some isotopes. These data are obtained during routine weekly calibrations of an instrument used for radiological safety at the Ohio State University research reactor using chlorine-36. The detector system used was based on a Geiger-Müller gas detector, which is a robust detector system with very low susceptibility to environmental changes. Clear annual variation is evident in the data. And that's kind of interesting. It says, with a maximum relative count rate observed in January, February, and a minimum relative count rate observed in July and August. And so, of course, the Earth's orbit around the sun isn't perfectly circular, and so we are actually closest to the sun, January, February, and furthest. So they're starting to piece it together, but they still don't know. Again, going back to the first article, is it a neutrino or is it some undiscovered particle? But again, the point, spend a lot of time on that, but to me it's encouraging. We're just at the beginning of understanding. Or go back to like last night we were talking about when Ernst Haeckel thought he'd found simple life, and published it in 1876. So we're just right at the forefront of saying, okay, decay rates fluctuate. We don't know why. We're trying to understand it. There's enough application. But from the discussion of, okay, can we trust a straightforward reading of the Bible? Again, just I'll make the observation, if decay rates are fluctuating now when things are physically stable, what might they have been during creation week or the flood? And if they were significantly larger, then not only do you have full consistency with the Bible, you also have full consistency with the other dating methods, which would again indicate the Earth being less than 10,000 years old. And then data on changing radioactive decay rates also available from Brookhaven National Laboratory, Long Island, and the Federal Physical and Technical Institute in Germany. And what's interesting also is both alpha and beta emitters show changes. And so I'm going to have a slide coming up here. I think it's maybe a couple slides that show maybe some of the effects of that. So anyway, this first one, this is a little more detail on the helium retention in zircons. And this was published back in 2006. And what they had done is they'd taken some zircons, and this was from an area just a little bit west of Los Alamos, New Mexico. I think this is where they got these particular zircons. And what they would do is they would date them by basically looking at how much uranium had decayed into lead. So if you look at that figure on the lower right, basically when a zircon forms, there's a few percent, there can be a few percent uranium incorporated into the zircon. And then the uranium-238 that's incorporated, it will decay to lead-206 over a period of time. And in that process of decay, it's 8 alpha decays, which essentially means you've generated 8 helium nuclei. Okay, so that's one way. And then the other way that's one way to estimate the age then would be to say, okay, how much helium is left in that zircon? And so that would, that would be, because you'd measure the diffusion rate. It's kind of like if I came in here and there was a balloon up on the ceiling, I'd probably come in here and I'd think, oh, they must have had a birthday party yesterday or something, okay? And then if one of you had said, no, it's actually when they had a big celebration when they had first finished building the building, and someone let go of a balloon and it's been up there ever since. I thought, wow, that's a pretty good helium balloon, usually. And so, but then, and of course that wouldn't be true, but the whole point would be, if someone was saying that, I'd have to take a lot of convincing to convince me that helium balloon had been up there for, many, many years. And so it's kind of the same thing. We see these zircons, we know how much helium could have been deposited in that zircon. We know how much is left, and it's way too much. I mean, way too much. What that chart shows is it's basically what they say is a creation model, and they published this model before the data came back. And so the creation model, if you look at the black dots are the data, so you see the black dots going along the top there, and then the theory are the squares, and so you see the data basically matches the creation model. And what the creation model is saying is that all that decay occurred within the last 6,000 years. In other words, it was during creation week, or the flood was when that decay occurred. And it's just based on how fast the helium would diffuse out of the zircons. Now, if we assume that the helium was deposited over billions of years, that's where you're off by about a factor of 100,000. And so again, it's very consistent with the decay, a lot of decay occurring. That's the assumption that the helium, although the lead was formed by helium decaying into lead, but it's also very consistent with that occurring relatively recently. And so again, that would be over the past 6,000 years, but most likely most of that would have occurred during creation week or the flood. So that's the helium retention in zircons. You get again, look at, well, what are some of the concerns? This is actually, to me, it's a really valid concern. It says if radioactive decay rates were greatly accelerated, wouldn't the resulting energy melt the Earth? And so in other words, if you accelerated the decay enough that you'd have that much radioactive decay happening relatively quickly. But the point is, to me, this goes back to, again, piecing the clues together. Changing the decay constant of an isotope would also change the energy released per decay. So we know the Earth didn't remelt. And so if the Earth didn't remelt or get too much hotter, then what would be the energy released per decay that would be consistent? So again, if we're allowed to pursue this type of research, then you can probably gain a lot of understanding. But again, it goes back to just, people are very careful. Even that's why the papers published would have to say, well, yeah, the decay rates are fluctuating. To be allowed to publish that, they almost had to immediately tie it back to, oh yeah, but this, couldn't possibly support the Bible, so don't worry about it, So they almost had to add that to the papers, kind of like when they said, well, if we put the Earth in the universe, you get rid of the need for dark energy, but yeah, that can't be relevant. And so, so you see an unfortunate pattern here. And so again, and then also a stretching of space. A lot of secular astronomers, a lot of non-Christians talk about space, being stretched, or the fabric of space being stretched. And again, it's really, pun intended, stretching our understanding, to understand, what that could all mean. But again, it's something we could certainly investigate. It would be another clue. And then they talk about ultrasonic cavitation of water, speeding up thorium decay. This was in the CERN Courier back in June of 2009. And it's actually, so this one's just a strange one because it talks about how, there's certain ways we know to accelerate radioactive decay, but usually they're really extreme. Well, they were reporting a factor of 10,000 increase indications just from ultrasonic cavitation. And so the only reason I mention that is it's very harsh, I guess I'll say, just a very intense process, but it was never thought that that could change radioactive decay rates. And so this wouldn't have been a good explanation. I just did want to show the effects of ultrasonic cavitation. This was basically at the Glen Canyon Dam in 1983. That dam almost failed because they had ultrasonic cavitation set up. And so again, this wasn't, but just to show what we think is a somewhat, at first blush you think, well, there's no way that could cause radioactive decay. It's actually a very, pretty impressive process. It said minutes that had a 32 by 40 by 150 foot cavern had been basically excavated just because the water started to cavitate in that way. So, and I think this was just regular cavitation. Ultrasonic, I think, was even, anyway. So it's, so just talking about, there's a lot of processes that can have much bigger effects than we might otherwise anticipate. There's also, you see inaccurate dates a lot. These are humorous but still damaging. And the reason is, I think we've all heard you can go out to Mount St. Helens and do potassium-argon dating. And they did potassium-argon dating on some of the lava flows, and they were coming up with ages of, like I think 3.2 million years was one of the oldest ages I've heard from when Mount St. Helens erupted. Okay, well, we all know that, no, it actually erupted a little over 40 years ago. And so that was kind of a, humorous, and then of course the answer is, well, we just need to calibrate, based on how much argon is trapped in the lava when the lava solidifies, and have this calibration. Another eruption, just to give an example, this was Mount Ngauruhoe in New Zealand. It erupted in 1954, and it was given potassium argon ages as high as 3.5 million years ago, which of course contradicts the Bible. But then in that same museum, so everybody knew that, okay, it didn't really erupt, they knew it erupted in 1954. That same museum, though, it was talking about this volcano that erupted 500,000 years ago. Okay, so it contradicts the Bible, and it was using potassium argon, but they just stated it as a fact. And so it's like in one exhibit, they just let us know that at best potassium argon is good to plus or minus 3 million years. And then the next, just down the hall a little bit, it's claiming something, to know something, where, that volcano that they said erupted 500,000 years ago could just easily erupted in 1600 and no one bothered writing it down. And so because again, that's within the error of that measurement. So that's, so there'd be no reason to believe the dates, but just think of the impression that makes on a person walking through the museum. Oh, that's really fascinating, but again, it was just it's like inconsistent even within that exhibit itself. And so again, have significant evidence against typical uniformitarian assumptions. We have the fluctuation in radioactive decay rates, carbon-14 in coal and diamonds, discordances in age estimates based on radioactive decay, significant helium in zircons, and significant errors dating rocks of known ages. Accelerated radioactive decay during creation weekend could explain those discrepancies. Now, I might have done the classic skipped a slide or forgot a slide. Okay, so this was the slide that I accidentally skipped. So this was the discordances. And so I just look at this chart, and this would be a typical, say a Earth Sciences textbook. And this was the Brahma amphibolite, and it was at the bottom of the Grand Canyon. A lot of times rocks are dated, and you only have one way of dating them. So like the volcanoes with the potassium argon, again, we know there's errors in that, but then we quote unquote correct for the errors, but those errors can be millions of years. In this case, though, there's some rocks at the bottom of the Grand Canyon, and they had the right isotopes in them so that you could measure the age using 3 different techniques. And so you see upper left there, that's uranium lead, gave an 883 million plus or minus 53 million year age. Then kind of in the middle towards the bottom, you had rubidium strontium, gave a 1240 million years plus or minus 84 million years. And then you had a samarium neodymium date that gave us 1655 million years plus or minus 40 million years. Okay, so at first blush, you look at that chart, and if you're not paying attention, you say, oh, well, that, not sure exactly how old the rock is, but it's got to be over 1 billion years old, right? Because we had 3 different dating methods, and every one of them said it's over 1 billion years old. But if you look a little more carefully, you notice those error bars don't overlap. Okay, so the error bars don't overlap. And so what that really means is that at least 2 of those 3 measurements have to be wrong. And just as easily, all 3 of the measurements could be wrong. Okay, so I'll give an analogy again. I keep picking on my remote, but okay, so remember we sent it to the one lab, and it said the remote was 100 feet long, plus or minus a foot. And I was like, but that just doesn't seem right. So I sent it to another lab. It says it's 200 feet long, plus or minus 2 feet. Okay, and then just to be positive, I'm going to send it to another lab. It says it's 300 feet long, plus or minus 3 feet. Okay, so the good news is I know it's at least 100 feet long, right? Because all 3, the lowest measurement was 100 feet, so I'm still confident telling everybody that your auditorium's a mile wide here, okay? But the point is that the error bars don't overlap, and so at least 2 of those, all I know for sure is that 2 of those 3 were wrong, and because I'm using the same assumptions, or whatever technique they were using for measuring my remote, if they're using similar techniques, there's a good chance that all 3 of those measurements were wrong. And so that's the situation you get into when you have discordances, is all you can say about this chart is 2 of those 3 are wrong. But you can start looking at clues. Okay, you have beta emitters there, you have alpha emitters there, you have isotopes of different atomic masses. Could there be a relationship? Whatever is causing decay rates to fluctuate now, is there a dependence on things like that, beta emitter, alpha emitter, the atomic mass? So all of these clues that are out there that we could investigate, again, if I'd almost just say if it didn't threaten atheism, because this is really this is an area you don't see a lot of atheists saying, "Oh, those silly Christians, they don't believe life just made itself," right? Because everybody's gonna think, "Yeah, you're right, life can't just make itself." So they don't want to go that route, or they don't say, "Oh, those silly Christians, they think they actually have free will." Well, they're not going to say that. And so where Christianity is attacked a lot is on the age of the universe, or the age of the earth. And so now that what's come to pass with the Big Bang, what we now know about carbon dating, what we now know about fluctuating decay rates, well, that argument against the Bible is also kind of collapsing for the atheists. And so this will be one that'll be interesting to see how it plays out over the next few years or decades. But it's so then going back to the summary. Again, we have the fluctuation in decay rates. If they're fluctuating a little bit now, it's not unreasonable to think they could have fluctuated a lot more during creation week of the flood. We see carbon-14 in coal and diamonds. There should be no carbon-14 left if the coal or the diamonds were more than even 100,000 years old, but certainly not the millions of years they're claimed to be. We have discordances in age estimates based on radioactive decay. In other words, you see where different, if you can date the same rock using different methods, you get basically results that don't agree. Significant helium and zircons, the helium should diffuse out. You also have actually too little helium in the atmosphere right now. Significant errors dating rocks of known age, and then again that goes back to the volcanoes and the potassium argon dating. And so again, that's all bringing this to being very consistent with a straightforward reading of the Bible. So true science is a Christian's friend. 1 Corinthians 10:13, no temptation has overtaken you except something common to mankind, and God is faithful, so he will not allow you to be tempted beyond what you are able, but with the temptation will provide the way of escape also so that you will be able to endure it. Again, in 1907, it would have been really tempting for me to just, off the top of my head, come up with some explanation for how there could be humans walking around on Mars and how to somehow make that consistent with the Bible. That's a temptation we have to avoid, and so just those types of temptations. And so again, just avoid the temptation to try to fit what's considered contemporary science into the Bible. I'll go back even to mention how Ptolemy came up with the idea that everything revolved around the Earth. Well, who's usually blamed for that? They don't say a Greek philosopher. A lot of times the church gets blamed for that. It didn't come from the church at all. It was just unfortunately, if it's true, apparently some within the church were trying to incorporate some known fact from the secular world into their teachings. And then 1 Timothy 6:20-21, O Timothy, guard what has been entrusted to you, avoiding worldly and empty chatter and the opposing arguments of what is falsely called knowledge, which some have professed and has gone astray from the faith. Grace be with you. And so just to end with this chart, Again, Romans 1:16, for I'm not ashamed of the gospel of Christ, for it is the power of God to salvation for everyone who believes, for the Jew first and also for the Greek. And so when it says not ashamed, I know this is a real harsh interpretation, but we as Christians, we need to be very confident in just a straightforward reading of the Bible. In other words, if you just had someone with no bias, which is very hard to find, but if someone that just going in with a totally open mind, they picked up the Bible, they can understand the Bible. We don't need to rely on a team of experts to somehow interpret the Bible for us, or people to kind of reanalyze the language or reanalyze the word based on our current knowledge or our current what we think we currently understand from the secular world. And so when I say not ashamed of the gospel of Christ, we need to basically just be able to be willing to defend the Bible as God's inerrant word. But that includes if someone asks us a question. If someone asks me a question and I don't know, I need to just, be humble enough to say I don't know, but I'm going to study and I'm going to get back to you. And so that's also very important. And then again, the ultimate goal of encouraging and helping people spend eternity with God. We need to. I'd almost say just have a strategy. Say someone does get interested. Okay, I don't know. Have you ever been on a mission trip where someone says they want to be baptized and the baptistry wasn't filled with water? It's kind of okay. So I don't want to get too tangential on you, but it's kind of like that. I mean, we have to actually be prepared for the fact, hey, someone might actually listen and decide, okay, tell me more. I'm excited. What do I need to do to be saved? What does the Bible say I need to do to be saved? And so again, I just mentioned a lot of times just the examples in the book of Acts. Where a person here believes, repents, confesses, is baptized, and remains faithful. I mean, those are examples are very powerful. But of course, there's a lot of other scripture in the New Testament we can use. But I guess just on this chart, we should always just always anticipate that a person will become open-minded, because they do. And that's what's and a lot of times I don't think of many times when all of a sudden someone says, okay, well, what does the Bible say? You're almost like surprised that they asked that. And I'm like, why was I surprised? That was the whole reason we're trying to encourage them, trying to get them to open up their mind, trying to steer them in that direction, trying to get them to objectively consider the Bible. So anyway, I just thought that's why I like to end with this particular slide. So at that point, I know we're about 5 minutes over, but I think we still have time for a few questions if anybody might have any. Yeah.
I missed something there, but I don't understand what the flood did. It might have done to change the decay rate.
Okay.
What is the process that you
Okay. So two things. So the flood on the carbon-14, that would change the carbon-14 to carbon ratio. And that would just be from the coal and oil and natural gas. If we look at the carbon buried in coal and oil and natural gas, and then again, if we look at like how coal seams are laid down, with the thickness of the coal seams, no soil mixed in with them. You'll see trees going vertically through coal seams. So powerful evidence that the coal was deposited during the flood. So that's where you could have changed, could have removed. Up to, and this is again agreement, secular and Christian, you could have up to 200 times more carbon in the environment before the flood rather than after the flood, and that could have a tremendous effect on the carbon-14 to carbon ratio. And then also, if the fountains of the Great Deep were heating the water, that would change the amount of CO2 that could be dissolved in seawater, which could also have an effect on the carbon-14 to carbon ratio, but only just very shortly after the flood. Within a few centuries, that would stabilize. So if we have a carbon date of something like 1000 BC, it should be pretty accurate. You'd expect it to be. So that was the carbon dating. Now with the radiometric dating with the long ages, that's the one, don't know how creation week or the flood would have changed the decay rates. And so at least right now, and you're like trying to think, okay, how could this get better, or what data could someone get? I don't even really know on that. But basically, right now, they're physically pretty stable. You think we might have an earthquake or volcanoes, but physically everything's pretty stable. Decay rates are still fluctuating. Okay, so if they're fluctuating now when things are physically stable, the postulate is, well, could they have been changing much more during creation week or during the flood? And so that's not at all a direct relation. That's just the big changes. At least when I was growing up, we were taught that those decay rates are just dead constant. They can't change. Well, now they're changing. We don't know why. So it's a step, at least us saying, okay, we don't know what could cause that. Maybe when we find out what causes them to change, then we could come back and say, okay, well, given biblically consistent conditions during creation week or the flood, that would explain much larger changes then, which would then, bring those very long radiometric ages, dates back into agreement with all the other 8, ways of estimating age, that indicate Earth's, less than 10,000 years old, and then also with not just the true science dating methods, I guess you'd say, but also just what the Bible, kind of straightforward of the reading of the Bible implies. So long answer, but I think there were 2 things. So the flood could affect carbon dating significantly, primarily any civilization that popped up within a few centuries after the flood. But as far as how it could actually change decay rates, that's just an observation. It was a lot physically stable now, much less physically stable creation week and the flood. So, okay, sorry, yeah, yeah.
Two things. One, I was just going to ask you how has your life as a scientific professional, how do you see the interactions with your fellow coworkers at that level of, lack of a better word, intellectuality, and their perception of God and of Christianity? And the second thing is, I was going to say, is my response to when talking with my fellow coworkers, which I find that a lot of the people that I work with, despite being physicians, are actually very religious
Yeah.
individuals.
Great, yeah.
More so than non-physicians,
Yeah.
graduate level individuals. And I found that striking. But on the occasion that I do find somebody who is questioning, I always go back to, well, I consider myself a scientist. And everything that I base off of is the scientific method. Is it observable? Is it measurable? And is it repeatable? Christianity, I haven't. It's observable. I see the persistence of Christianity throughout the last 2,000 years. It's measurable. I have recordings of the Bible and its persistency as far as its accuracy over 2,000 years. As we gain more data, we get more archaeological evidence to the original Greek text, the Aramaic text, and we compare them to what we got today. They're the same. And then, as far as the other portion of observability is the overall complexity of life, and that's usually the thing that really gets
because you're a physician.
sheer complexity of life. And putting all those things together, how do you account for what you're observing? And it does make them think. But I was just curious as to how what is your life then in regarding to your Christian faith and NASA and
well, very, very similar. And so that's what's ironic too, is there's this portrayal that researchers and scientists somehow don't believe in God and that's not my experience at all either. And so it's actually very refreshing to hear that's your experience too, because you're in a different field and you're a different part of the country. And I'd say that, by far the majority of the people I work with believe in God, and and it's and then the ones that you can't really tell, they're very open, just to I guess you'd say just normal discussion. And I'm sorry, could everybody hear the question? Okay, because it was a great question. I didn't want you to have to repeat the whole thing, but it was perfect. Yeah. If you want to use the microphone real quick? I'm sorry. I'm not sure if people online can hear it or not, but I heard it all and it was perfect, so I didn't want to interrupt and say, hey, go to the microphone. Yeah.
Flip the switch on top.
Oh, down here? Nope, it's there.
Yeah, it's working.
So yeah, there's this perceived false dogma in society that researchers, scientists, physicians are all atheists. that we've all gotten to this point that we are just so smart, we're smarter than the average person, that we've all decided that there is no God and there can't be a God, and that we've collected all this data. But in my just last 7 years that I've graduated and been in that community with those individuals, I don't find that. I find that majority of them are religious, and it is refreshing. I do think, though, that most of us tend to be silent about it, and I think that has perpetuated the idea in society that, those people are smart and they're not saying anything against what mainstream media and scientists are saying, and therefore what the people that are the loudest are saying, that must be true.
Yeah, that's a great way to phrase it. Yeah, it's just the people that get for whatever reason, the people that get the most attention are the militant, I guess you say militant atheists, or the people that are the loudest. But my experience is very similar to yours. Well over, the majority of the people that I work with, they believe in God. I'd say I've never run into anyone that wasn't willing to have a calm, non-confrontational just discussion about anything. And obviously you don't want to set a person up that differs in your opinion and get them in front of 100 people and start arguing with them. But it's, so it's, people are very much more open to God and realizing that God created the universe than the mainstream media, I'll call it, would imply. And again, that's probably an overused term also, but just the general impression, just like you were saying. And so again, all I was saying is it's really glad that you being a physician in a different part of the country, having essentially the same experience that I'm having working at NASA, down in Alabama. So. Yeah, it's a good encouragement. Yep. Yeah.
No, I was going to be up here.
Yeah. You're in trouble. Yeah.
So, I just wanted to know if you were familiar with the book, The Annals of the World by James Ussher.
So I'm familiar with it. I haven't read it.
Oh, you have to read it.
Okay.
He got a bunch of historians. He's a historian, and he got a bunch of historians together, and got a date going back as far as they could that they all agreed on was a true date.
Okay.
And it was Nebuchadnezzar's death.
Okay.
And then he wrote this book. It's not a book; it's a tome.
Okay.
And he dates forward and he dates backward from that date. And it's very detailed, and he follows the biblical patterns mostly. And it's the first time I ever saw those different lineages in the Bible put to use.
Right. Okay.
He was just very clever with that.
Yeah.
And he got back to the date of October 23rd, 4004 BC. It's the creation date.
Okay.
And it's so detailed and documented the way he did this. I was just impressed. Even if you didn't agree with every little, dot and tittle about, what he wrote, this book, it was truly fascinating.
Okay,
and fascinating the way he did it.
Okay.
A question, I'm not real familiar with carbon dating and stuff, When you say decay, the atoms decay, they throw off the electrons or whatever.
Yeah, so carbon-14, it'll actually spit out it's equivalent, it's called a beta decay, but just think of it, just spits out an electron, spits out a negative charge, and so it actually decays back into nitrogen-14. It's kind of strange to think about, carbon 6 protons, so carbon-14 is 6 protons and 8 neutrons. So if you spit out a negative, you're basically converting a positive to a neutral, and so you end up going back to, you end up a neutral to a positive, and so you basically end up going to a nitrogen-14.
So would this process continue? I mean, as more time passed by, it would spit off something else?
Yeah, it's always half of the remaining carbon-14 always decays to nitrogen-14. Now nitrogen-14, half of the remaining carbon-14 every 5,730 years decays to nitrogen-14. Now nitrogen-14 is stable, and so it's, as far as we know, it just stays nitrogen-14, so it's 7 protons and 7 neutrons. And so the carbon-14 with 6 protons and 8 neutrons spits out a negative and ends up 7 protons, 7 neutrons, with the nitrogen-14, and the nitrogen-14 is stable. Again, as far as we know, but that's everything we've measured.
Did you ever hear about those 2 scientists that thought they could actually create man like God did?
No.
Oh, yeah. And so they got all these rabbis and priests and everything else together. They got God to come down to listen to them. He says, we don't need you anymore. We know how to create a man. We can create anything from that. So God says, so go ahead. So they went down and scooped up some dirt, and God says, use your own dirt.
Okay. All right. So, well, thank you for sharing that. That's good. Yeah, exactly. Yeah, you can. Sure. Other questions? Yeah.
Do you think that, the book that Lee Strobel wrote, A Case for Creation, have you read that one?
Yeah.
Yeah, do you think that's still current? I guess it was written about 20 years ago. So.
Yeah, I think on ones like that, it goes back to just, again, looking at the method, he was using. He came from, an atheist, and as far as I understand, he was kind of determined to disprove the Bible, and he figured out, proving the Bible. And I'm not sure all his conclusions, were completely right, and or all the technical detail behind them. But I'm always just, I'm always fascinated by books like that, when a person will, basically they set out to prove one thing, and they end up proving to themselves another thing. And so again, I haven't kept too much track on where he's gone in the last 20 years or so. But I think I think they all.
Pretty reasonable for us now.
Right.
One of the things they pointed out is that the old idea of the early Earth and some lightning bolts hit, and all of a sudden molecules
Oh, yeah.
made and life comes from that.
Yeah.
And he talked to one scientist, and the scientist said, well, nobody really believes that anymore because all these factors
Yeah.
couldn't possibly do that.
Yep.
But he said every textbook to this day uses that example.
Yeah.
And so everybody that studies science goes through the idea that, well, that's how everything happened, is the lightning bolts in the early.
Yeah. Warm little pond with some salts and et cetera, et cetera.
Waste the error,
Yeah.
and everybody thinks that's fact too.
Yeah. And I think that was the comment that was made over here, though. By the time they get through medical school, they figured out, they've learned enough to realize, no, that doesn't work. And so then that's why you get this pendulum swinging back, where they realize that there's a God again. Yeah. Good comment. Thank you.
Along that same line with what Chris said, and you and this gentleman here, but with the it seems with the greater education, the people that you hang out with, your knowledge, yours as well, the people that you work with believe that there's a God. Yet, what my kids coming out of public school, that's not what academia is trying to teach the kids. They're holding on to the fact that there is no God, and it's really, how do we get that corrected? I mean, how do we, and that's, I feel like we're under attack there with that, but and maybe this is for a whole different conference, but a lot, but it's a big deal. These kids are being raised up, being told that what the Bible says is untrue.
Yeah. Yeah, and so that's one, a few thoughts on that. Definitely be great to talk about that more tomorrow morning too. But first is a little light goes a long way. And so I don't know, you've probably all been on those cave tours where they tell everybody to turn off all the lights, and just so they show you what pure blackness is. And then sure enough, one guy has a little light on his watch, and it's not me. I start buying cheap watches, so that doesn't happen to me anymore. But and everybody immediately is like, cover your watch or turn your watch. So there's a little tiny light that you knows, but when it's pitch black, a little light goes a long way. And so to me, that's one of the first things. That's why just any opportunity we have just to get people thinking. And it's not, don't have to make them sit through 3 hours of lectures on a Friday and Saturday night. Thank you again for doing that. But just to point out things like, well, did you choose, to be an atheist? And then, and of course, if they say yes, again, you say, well, then if you really chose, atheism's wrong. Or like was pointed out about life and the life just made itself a lightning striking a pond, and just say, well, then if that's all that happened, why can't we make life? We can make airplanes. We can make, so just get them thinking. So a little bit of light goes a long way, and then ideally try to get them into the Bible. So I'm not sure. The reason I say that, there's been societies societies tend to become dominated by false religions, and it's very hard to fight that within the society. We'll talk about 1 Kings chapter 18 some tomorrow. Where everything God had done for the Israelites, and they were out there, worshiping Baal and Asherah, and they wouldn't answer Elijah when he said, well, Baal and Asherah, worship them if God worship, and so again, that was, and the most influential people in their society were pushing that way. So they couldn't really, so it's almost like one-on-one. But the good news is, if we just tell a few people, it doesn't take long to convince them. Hey, we're not being told the whole story, and then of course. I think the other one that unfortunately we kind of, so we can teach that it's scientific that life just made itself, even though we know it's false. But we can't, bring in the fact that, well, if life didn't make itself, maybe it was designed, without saying anything more than designed, because, that's religious. You're not allowed to have that. So I don't know how we let things get to that point where you're not allowed to speak the truth, even speaking the truth in love in our education system. So that's kind of odd. But also, I know a lot of you have kids, and talking to some, and even if you're homeschooled, they're involved with other kids, or if you're in public schools, they're involved. Well, just having them tell their friends, just mention that to friends, and mention it at a very young age also. Even a 5-year-old should realize that, they respect their teachers, respect adults, but every now and then they're going to run into an adult that's unfortunately been misled or deceived themselves, and they're going to be trying to tell them things, like don't believe the Bible, or believe that the universe and everything in it just made itself. And so let them know at 4 or 5, and then give them a few specific examples that they can try to counter that with. So that was kind of a non-answer, but it's as far as actually being an overhaul the educational system, that would be really, really hard. But I also heard that I think it's over 11% of families now with homeschool age kids are homeschooling, and so again, that's not I know a lot. That still means that's a lot of kids. If and those are children that can have just a very Christian influence. Anyway, sorry, non-answer, but just some ideas. Thanks. Yeah.
Not so much a question, but maybe even more of a comment. But the more I study the Bible in the history, I treat it as a history book, and I think it's really a history book of everything. And I think that's one of the problems, like we were just talking about school too, is it used to be a history book for school about 100 years ago, 200 years ago, but now it's completely not. I mean, they've reversed it. They tried to take everything away from it.
Yep.
And maybe we didn't fight back hard enough or whatever, but we let it in, and since they've taken that out, that they keep trying to take everything else out that has anything to do with God. Mm-hmm. And I think that's preventing a lot of what's going on too. But the history, along with the science, to me, proved the Bible. The more you read it, the more, it explains, like the Tower of Babylon explains how we got languages, how people got in different continents, how they could have been spread to all the different continents at the different time. Just everything in the Bible lines up with everything. And talking about decay, once sin hit the world, everything started decaying, and the Bible even says that the world's going to decay, basically.
Yeah, and what we're seeing going on with the genome and everything else. But no, that's an excellent comment. But again, the good news is, I'll go back to a little light goes a long way. So even if we only make it a point to talk to 10 people a week, that still is going to have an effect. And like Chris was pointing out, a lot of they're not going to recoil in horror when we bring up the subject. It can take you have to find an opportunity to bring it up, but a lot of times it'll be amazing how many people agree with us, and then we're encouraging them, and then through that discussion, then when we do invite them to church or we do invite them to a Bible study, they're very, or you'll get, I know this probably happens a lot of you too, if you're the person at work that they know is a Bible believer or goes to church, well, if they have something going on in their personal lives, or if there's a death, or if they need even a Bible verse for a funeral, a lot of times if they have, a lot of people have no connection, they'll give you a call. And so that's a really important connection to make also. Yeah.
I don't know if you're planning on bringing this up tomorrow, but this topic is very important, especially for those that are already Christians. There is that prevalent belief that two groups of Christians, we call them the young earthers and the old earthers.
Right.
And granted, is this a salvation issue? If somebody firmly believes in Jesus Christ and God and follows the commandments, but they believe that earth is result. Is that a salvation issue? I doubt it. I don't think so. But there's a danger, and the danger is, we're told to build our foundation, our house, on the rock.
Uh-huh.
As Christians, the foundation is the Bible. And the foundation of the Bible is Genesis 1.
Uh-huh.
If you undermine that, you undermine the rest of it. And that's the danger.
Right.
Which is why this is very important.
Yeah. Yeah, because I think this is and I will mention it just briefly, but I had a lot of conversations when I was converting from atheism to Christianity. And some of them were on things like, one I'll mention, if you're here tomorrow morning, please stay tuned because I'll do it real quickly tomorrow morning. But I was talking with somebody and I'd run across an article in National Geographic about how maybe there's this really big Mesopotamian flood and Noah just thought it covered the whole earth, and so that's why. And so I was one of my roommates who was studying with me. Of course, he was a Bible believer, which was great. I mean, God put all kinds of very patient people in my life. So it's like, okay, hey, this is great. We're going to have, we'll finally have some commonality. Because I really liked him. He's a really good Christian guy. Really treated me nice. So I went and showed him the article, and he goes, no, the Bible says the flood covered the entire earth. And at the time I was kind of like taken aback because I was like, I'm trying to work with you here. What's the, but in hindsight, if he had said, oh yeah, maybe the flood was just a local flood, well, I would have still liked him. He's a nice guy, but that would have discredited the Bible because I'm just like, no, if I pick up the Bible, there's no way to me God could have made it any clearer that the flood covered the entire earth. I mean, if you read through Genesis, what else could God have said? And it's kind of the same thing with days of creation. I mean, there's a number with the days. There's evening and morning with the days. In Exodus, he refers back to in 6 days God created the heavens. So I just go back to, okay, if God had wanted it to be anything but what else could God have done to make it obvious that he meant literal days? And it's not so some people that it doesn't. So I'm agreeing with you completely. We can't let that foundation go now. That's a very important foundation. And the good news is, as true science is advancing, it's becoming easier and easier for pretty much everybody to accept the biblical account. And to me, it was, I know I probably bored you all to death with the changing radioactive decay rates, but that's actually very exciting. And the whole point is because that was kind of the last one that is like, well, if those decay rates really are constant, how could this really work? Well, since 2006, we know that they're fluctuating. So there's no reason to have to just not. We're always supposed to accept a straightforward reading of the Bible, but now there's just no quote unquote scientific reason to not just accept a straightforward reading of the Bible, and that's kind of the key to building our foundation. Now, all that said, people will say they don't care about the age of the earth, and then they might ask us a question, but they can't understand. Well, why does God? Frankly, like pain and suffering, you get that. I know you guys hear that a lot. Well, how can a loving God allow pain and suffering? So they might totally accept the Bible, but there'll be other things that they are bothering them. So I don't feel like I have to convince people. that it's 6 days, and if they're really truly not interested. But it's when that starts to cause someone to question the Bible is when it becomes really important. And I think if someone really gets into it, really looks into the linguistics, again, if it's okay. So I've never seen a way someone can say anything but a straightforward reading of Genesis without just basically distorting the scripture so much that they could make the Bible say anything they wanted it to say. Because I could apply the same techniques to anything else in the Bible, and basically it goes back to like the Big Bang. You can set it up so you can make the Bible say anything you wanted to. So anyway, sorry, that was a really long way of saying I agree with you completely. So, thanks. Yeah.
One of my working days, I was an engineer in the engineering department, and I always like to say to the young engineers that anyone who ever worked in an engineering environment couldn't possibly believe in the theory of evolution.
Yeah. Yep.
And they look at me like, for a science person, how can you ever say that? Because nothing ever works by accident.
Yeah.
You have to force it to work. You have to get rid of every possible other way
Yep.
to do things. And the only one way will make it work.
Yeah.
Accidents just aren't going to
Right. It's hard enough to make it work on purpose. So yeah, no, that's a good way to phrase it. Yeah. Yep. And I've even gotten to the point I don't like going to the doctor at all, but I'm just flat out nervous going. I don't think many are, like you were saying, but if I had a doctor that was just like a devout evolutionist, I think I'd just take my chances at home in the living room. Because yeah. Sorry, I'll come up here though and talk. At least I know who I can go see now, so that's good. Yeah. All right. Any other questions or thoughts tonight? All right. Well, thanks again for attendance. I'm really looking forward to seeing you guys tomorrow morning. So, all right, thanks.
Thanks for the applause. I rarely get that on my way up here. Appreciate that. We're going to have a prayer and then a couple brief announcements, and then Mr. Ken is going to lead us in a song on our way out. So would you bow with me as we pray? Father, as we bow before you, we're so grateful for all that you've given to us, and especially when it's pointed out to us so well, we're so grateful for the earth that we live on, for all that you've created for us, Father. And we see your beauty in everything that surrounds us. You are just such a great and generous God, and we thank you so much for that. We thank you especially this weekend for Dr. Houts and for his scientific knowledge, and for showing us that science always confirms the Bible, and for giving us ways to share that with those around us, Father. We pray that that'll be a way that we can do that to bring others to you, Father, closer to you each and every day. For that is our goal, is to bring people to you, Father. Father, we also are mindful of those who are ill, unable to be with us. We ask that you be with them, and if it be your will, heal them quickly and bring them back to us as quickly as you can, Father. Father, once again, we thank you for this knowledge that's been imparted on us, and we pray that we'll use it each and every day of our lives to bring others to you, Father. We thank you so very much for your Son, Christ Jesus, and for his wonderful sacrifice for us. It's in Christ's name we offer this prayer. Amen. We thank you for attending this evening, whether you're here in person or online. Tomorrow morning's class will be, hold on, I have to adjust my glasses here. Evolution is Religion. That is at 10 a.m. It will be live streamed, and then those go into the YouTube archives for us. And then at 11 o'clock, Dr. Houts will present to us From Athens to Christ. Once again, that'll be live streamed, and then it'll be placed in our archives afterwards. So, Ken, if you wouldn't mind leading us to a song.
You've all been sitting there so nicely. It's time to stand up and stretch. We're just going to sing the first verse of This Is My Father's World. This is